Grace and peace to you all, my lovely viewers, and happy 2024. This is Donald Siame, author of Hidden Mathematical Genius Within Revealed. Our question today is, the fourth term of a geometric progression is 54, and the seventh term is 1458. Calculate the sum of the first term of the first 10 terms. Okay, so this is a geometric progression, and we know that geometric progression is a progression where there is a common ratio between consecutive terms. Okay, and our question here is asking us to calculate the sum of the first 10 terms. So solution. So sum of a GP is given by the formula. Okay, sum, that is S sub n, is equal to A then in brackets we have r to the power n minus 1 over r minus 1. So that is the formula of calculating sum of the GP. Okay, now from that formula, we're supposed to have the value of n, which I'm sure we have. Calculate the sum of the first 10 terms, so n is 10. Okay, A is the first term, we don't know, and R, common ratio, we don't know. So what we do, we need to calculate for A and R from the information which is given. So the first information we have is the fourth term of a geometric progression is 54. The fourth term of a geometric progression is 54. Okay, so when you are finding for the position of a term in a geometric progression or any term, the formula is, we say it's nth term is equal to, it's A r to the power n minus 1. A r to the power n minus 1. So here we have fourth term. So you say fourth term is equal to A, since we don't know A, it's A, R, we don't know R, n, in this case we are finding for n for fourth term, so meaning n is 4, so it will be 4 minus 1, and 4 minus 1 is what? 3. Okay, so fourth term is equal to A at the power 3. Now we are told that fourth term is 54, so this is equal to 54. This will be our equation 1. Okay, second statement, we have the seventh term is 1458. So again you say seventh term is equal to A at the power, n is 7, so 7 minus 1 is what? 6. Okay, so this is equal to, it's 1458. So 1458. This is equation 2. Okay. So what you do is we are going to solve for A and R from the two equations simultaneously. Okay. So equation 1 we have A at the power 3 is equal to 54. And equation 2 is A at the power 6 is equal to 1458. Okay, so to solve the equation, what we need to do is we're supposed to have just one variable in an equation. Then it will be very easy for us. So in short, we're supposed to eliminate one variable the two variables we have, because we have the variable a and the variable r. So which variable is going to be easier for us to eliminate? Yes, we can see that we have a here and a there. They are just have the same. They are in the same order and same coefficients. So the a's can cancel out. And how are we going to cancel them out in this case? Okay, so in this case, the only way we can cancel out the a's is by division. Okay, so we can divide, in this case, we can divide equation 2 by equation 1, since equation 2 seem to have a higher order than equation 1. So we can divide equation 2 by equation 1. Okay. So say equation 2 divide by equation 1. Okay, so we are going to have, it's a at the power 6, that is in equation 2, over a at the power 3, that is in equation 1. This is equal to 1458, that is in equation 2, over 54, that is in equation 1. Okay, so a and a will cancel out. Then we are going to have a cubed in a to the power 6. We are going to remain with a to the power 3, that is a cubed. Oh, sorry, r cubed. So we have r cubed is equal to, then what is 1458 divided by 54? Okay, so 1458 divided by 54, you get 27. So r cubed is equal to 27. Okay, then for us to remain with r, what you do is you do the opposite of the cube. Okay, the opposite of a cube is the cube root. So you cube root to both sides of the equation. So if you introduce the cube root here, the cube root and power 3 will cancel out. So we are going to remain with r is equal to then cube root of 27. Okay, so r is equal to, what is the cube root of 27? Cube root. Okay, so cube root is the number which you can multiply 3 times by itself to get 27. That is what? 3. Yes, we know that 3 times 3 is 9, times 3 is 27. So r is equal to 3. So that is the value of r. Okay, so now that we have calculated the value of r, we need also to calculate the value of a. So we go back to our equations. You can use either equation 1 or equation 2. And where there is r, you put what? You put 3. Okay, so let's use equation 1. So equation 1, it's a r cubed is equal to 54. Okay, so r is 3. So you put 3 to the power 3 is equal to 54. So what is 3 cubed? 3 cubed is 3 times 3 times 3. That is 27. 27 times a, that is 27a, is equal to 54. Okay, so we are solving for a. So since we are solving for a, we are going to divide by 27 to both sides of the equation. So over 27, and this side over 27. So 27 and 27 cancelled out. So we have a is equal to 54 divided by 27. Yes, you get 2. Okay, so we have the value of a and of the value of r. So now we can calculate for sum of a GP of the first 10 terms. Okay, So therefore S sub 10 is equal to, okay, so the formula is A sub n is equal to A, then in brackets we have r to the power n minus 1 over r minus 1. Okay, so we have A sub 10, that is n is 10, so A is 2, so 2, in brackets we have so r to the power n, r is 3, n is 10, so 3 to the power 10 minus 1 over 3 minus 1. Okay, then you say A sub 10 is equal to, so we have 2 in brackets, we have what is 3 to the power 10. Okay, 3 to the power 10. 3 to the power 10 is 59,049. So 59,049 minus 1, we are going to have 59,048. 59,048. Then over, what is 3 minus 1? That is 2. Okay, so S sub 10 is equal to, so without wasting time, these 2 and these 2 cancel out. So the answer is 59,048. So that is the sum of the first 10 terms of a GP, a geometric progression. Okay, given that the first term is 2 and the common ratio is 3. Okay, thank you so much for your time.